This is hybrid energy power system with battery energy storage system. In this, PV source is available and fuel cell is there. The fuel cell will be supplied from the hydrogen tank, which can be generated using this electrolysis. This is electrolysis. The hydrogen will be supplied to the fuel cell here. This is the fuel cell, and the fuel cell is connected to the boost converter. The boost converter is connected to the DC load. It will be also connected to the PV source and the battery energy storage system. Here in this battery energy storage system, this is the actual measured SOC. In battery, we have provided 20% as the initial SOC. Here 20% is the initial SOC. So from that we get the measured SOC, but we have to convert it in terms of hours. This is measured for 1.2 seconds. We have to convert it in terms of hours. So before that, this is the initial value provided in the battery SOC. And here we are removing the percentage, 20 divided by 100. Okay, here 1 by 100 is multiplied. So 20 into 1 by 100. And that is compared with the measured SOC. Okay, let's see whether it is charging or discharging the temperature here. And it is converted in terms of hours. So from seconds to 60 is multiplied with 60. So seconds is converted to minutes. And minutes multiplied with 60 minutes is converted to hours into 24. So for 1 day, how much it will be? That we can check it. And this is the maximum SOC. So whatever we have measured for 1 day, that is subtracted from the maximum SOC, and that is termed as the actual SOC. That is the SOC measured for 1 day or for hours. From seconds to hours, we have converted it. Okay, from 100%, it is charging. So the SOC increases, and after 0.5 seconds, it starts to discharge. This is the SOC from 100% to 0%. Here it is stopped at nearly 45%. This is the remaining useful time. So how much time the battery can withstand? That can be determined using this. So when the battery is discharging, still it can withstand up to 1.2 hours. And that can be determined by using this. So from SOC divided by 100, and it is 60 divided by 24, that is number of hours is 24. So that SOC calculated for hours divided by 100 divided by 24 into 60, we will get exactly how much hours it can withstand. And this one is optimization. Here we have provided PV supply and battery parameters, that is PV voltage, current and power. Similarly, battery voltage, current and power, that is fed to the ANN, and from that we will get the duty ratio for the PV based boost converter and bidirectional buck boost converter. Those duty ratios will be provided to the bidirectional buck boost converter. Here this is the battery parameters, and here this is the duty ratio generated from the optimization control. Is given for pulse generation, and it is fed to the bidirectional converter switches. And here we have used these three port switches for combining the outputs from the bidirectional converter when battery is charging and when battery is discharging. First one is of voltage. When battery is charging, the battery voltage is the output that is provided here. When battery is discharging, the load voltage is the output that is provided here. Similarly, this is for current. When the battery is charging, the battery current is the output of the converter that is provided here. When battery is discharging, load current is the output here that is provided. Similarly for power. When battery is charging, this is the power that is from battery. And when battery is discharging, the load side power is the output of the power, output of the converter, output power of the converter. Here why it is oscillating means the converter is switching over battery charging and discharging modes continuously. So the voltage across the converter while battery is charging is 240 volt. That is the battery voltage. And when the battery is charging, sorry, when the battery is discharging, 400 volt is the output of the converter. So here it is oscillating. When the battery is charging, 240 volt is the output of the converter. When battery is discharging, 400 volt is the output. So in this stage, the battery is continuously switching over charging and discharging modes. Hence the voltages appear like this. And after 0.5 seconds, the battery is clearly discharging. So it is 400 volt here. If you see battery voltage, it will be normal 240 volt without any ripples. Okay, here you see means the battery voltage is of no ripples when the battery is charging. But here as we combined both battery charging and battery discharging outputs, when the modes are switching over continuously frequently, the output is appearing as oscillating, but actually the output is constant. And here, this is for energy management. Here, for energy management, we have to switch over the battery, energy storage system, and fuel cell when the PV is not providing enough supply. So here, when the PV power is greater load power, the battery will be charging. And when the load voltage is greater than 400, the battery will be charging. Otherwise, the battery will be discharging. Similarly, when the PV power is less than or equal to 5% of load power, then the fuel cell will be connected. Otherwise, fuel cell will not be connected. We can change it to 10%, 20%, whatever our requirement. According to that, we can change it here. So the battery energy storage system will provide the charging when the power is higher than the load power and the voltage is low voltage is higher than 400 volt. And it will be discharging when any of this condition is not met. Similarly, fuel cell will be connected only if the PV power is less than 5% of load power. In case of load voltage, first one is boost converter input. Second one is load voltage, is around 400 volt. Third one is load current, 100 amps. Here again, for this, initial value of SOC is 20%. We are converting, that is, we are removing the percentage here by dividing it by 100. Similarly, for this also. And initial minus actual SOC, that is converted in terms of hours from seconds to hours. So here into second, into 60, we will get minutes. Into 60, we will get hours. Into 24 for 1 day. And that is subtracted from 100%. That is the maximum SOC. And the resultant SOC is provided as output. Initially, it is charging when the PV is available. When the PV is not available, it is discharging. And this is remaining useful time. As previous, we are removing the percentage here, 1 by 100 from the SOC. And here, we are converting it in terms of hours. Here, because it is the SOC is measured for 1 day. So divided by 24 into 60, we will get it for hours. That output is provided here. So with the current rate, it can withstand up to 1.2 hours.